Alright, so, disclaimer, this is by no means a professional explanation of anything. I'm just saying what I know, okay? Ask the teacher for any professional questions. Alright, so my name is Alejandra Sanchez Murillo. I could not be bothered to record myself talking because the camera on my computer does not want to work, so you'll just have to stare at that one image of myself for the entire video. Maybe I'll add in some effects or not, who knows. The editing software in this thing isn't that good either, so sorry for that. And chemistry is the study of compounds and elements reacting, or just studying those things on their own. It's that simple, believe me. And organic chemistry is basically the study of organic compounds. Organic compounds are basically any compound that has carbon in it, unless it's carbon dioxide, carbon monoxide, carbon trioxide, and any carbon oxides. And I think a few more. So yeah, don't think carbon dioxide is alive, because it's not. Because if it was, then it would be the most evil thing in existence, ruining our lungs and stuff. Although it does feed plants, so I guess it's somewhat good. But we'll keep it as an evil thing. It's pretty evil. And inorganic chemistry is basically studying stuff that isn't organic, like steel, gold, uranium, tungsten, and basically those compounds and what they do, how they interact with each other, and the atoms. It also explains the periodic table. You know that thing that somewhat looks cool in a blanket until you have to wash it, because then it's like numbers all over the place. Actually, I don't have a periodic table blanket. I might get one day, but right now there's no budget for it. Yeah, I think it's obvious by the fact that the computer's camera doesn't work that there's no budget in this. Also, apologies if the audio in this thing is horrible. There was no budget for that either. And what I recommend to other first year students, do not think it's complicated, okay? Chemistry, it's not complicated, alright? The worst you're gonna see are a few formulas here and there, and like having to understand how the entirety of the universe works, but that's not hard, okay? I did in the first class. It's pretty simple. It's pretty simple, yeah, it's pretty simple. And we learned in the course, okay, let's see if I remember everything. Please forgive me, teacher, I'm probably not gonna remember about 50% of the things. But they're in there, I just don't know they are. They're in my brain, I just don't remember when or how they got in there. Okay, so first we learned inorganic chemistry. We learned about atoms, about orbitals, about balanced electrons, that atoms are made of electrons, protons, and neutrons. The atomic number, the periodic table, yeah, that little number on the top, that measures the electrons and the protons in this thing. And the other number, the atomic mass, that measures the protons and the neutrons. Now, the atoms are made of nucleus and the orbits, okay? That's not how they actually look like. If there's empty space between the atoms, then that would be a big problem. That's just a model to understand how they work. Okay, the nucleus of the thing, it's made of neutrons and protons, okay? And then there's a thing called isotopes, which if you change the amount of neutrons in the thing, you make an isotope. Now, most of the times it's perfectly fine, but in the case of cobalt, yeah, in cobalt, normally it has like, I think 30 neutrons. Yeah, if you duplicate that, you get 60. Cobalt 60. It's pretty dangerous. If you ever find a stick of that thing, it has literally on it, drop it and rub, because it's super radioactive. Do not touch it. I have no idea why you would ever come in contact with one of these, but drop it and run away. Sorry for that. There's that. We also learned about how they bond and about valence electrons. Electrons, they have these orbitals, and the one at the outer exterior, that's called the valence electron thingy, and that one is the one that interacts with other stuff. Now an ideal atom has 8 electrons at the end. That's the most stable stuff, like I think oxygen. I think stuff that has 8 or so electrons at the end is pretty stable. stuff that doesn't have 8 or so electrons, like hydrogen, lithium, beryllium, francium. Yeah, they're super reactive. Do not come into contact with those on their own. You know, when they combine with other stuff, perfectly fine. But still, don't come anywhere in contact with lithium. That thing's lethal. You know, it's what's in batteries. Who came up with the name lithium? Sounds like a Greek god, but that's I don't remember any Greek god's name. Lithium, Lily. Did I name lithium after the flower? Who knows? In any case, yeah, depending on the balance of electrons, depends on how stable it is. And, you know, for the stuff to bond, you can't just stick the two together. Most of the times, you need to heat it up or give it a ton of energy. And you know what happens when you give an atom a bunch of energy but it doesn't connect with anything? It blows up. That's how Hiroshima died. Pretty sad if you ask me. Okay, what else did I learn? There are orbitals. Okay, so electrons, they're just sitting there. They're spinning around all the time. And there are areas where they're the most likely to be in. It doesn't guarantee it's going to be there, but that's where most of the times it is. Those are called orbitals and they look like flowers. They're also in 3D, right? You cannot draw atoms in 2D because if you draw them in 3D, it's a big mess. Don't do them in 3D unless, I guess, they ask you to. But don't worry, the teacher isn't going to ask that. At least she didn't ask us. Good luck if she asks you. Orbitals are in 3D, you know, flower thingies. Yeah, that's where electrons are the most likely to be. Okay, after that, after the periodic table, after bonding stuff, I think there was like a big break. Christmas? I think so. And after that, we went on, I believe, with organic chemistry. And in that one, you know, it's basically just learning how to use stoichiometry. Oh, I forgot about that one. Oh no. Okay, so stoichiometry is basically just how you name stuff and like the relation between stuff and other stuff. I think. Okay, and stoichiometry is also how you name compounds, right? The oxides, the acids, the bases, the salts. I think there was another one, but I cannot remember it right now. And you know, for oxides, you just put carbon dioxide. Let's go with that. Also, carbon dioxide. You know, the technically speaking, correct name would be monocarbon dioxide, but that's a long name, and the mono makes it look complicated, so we cut that out, I guess. Also, because I think that out of everything, that's the most common thing we encounter. So making the name easy to say is important. You know. Okay, all right. Carbon dioxide. Carbon dioxide. The dio is the Latin two, two in Latin. In Latin, okay. And die, not dying, dying. I died. No, die as in di. Okay, that means two. And because there are two atoms of oxygen and one of carbon, you get carbon dioxide. Right? That's for oxides. For salts, it's I think a nonmetal with hydrogen. A perfect example is hydrochloric acid. No, it's an name. That's an acid. Hydrochloric acid. That's, okay, so a nonmetal with hydrogen, that's an acid, right? A salt is a nonmetal and a metal. All right, let's go with salt. Sodium chloride. You know, it's funny how sodium on its own is like this very reactive thing, and chloride is this super deadly gas. With like when you mix them, you get salt. Like the guy who mixed the two together to make like a super deadly weapon to poison his enemies was probably really disappointed when it didn't work. I wonder if after that he was like, wonder why this didn't work, and he tasted it and I was like, interesting. I'll make a bunch of this. Or I think they just how did they discover salt? Does it naturally form? Because I would explain it how they came across salt. Salt. Oh, okay. What was it? Bases. The bases, they are, I think, hydrogen with a metal, and then there are the hydroxide, which is basically anything with an oxygen and a hydrogen. It says OH. Okay, pretty simple. After that, okay, I was going with organic chemistry. You learn how to use stuff like prefixes. I do not remember them right now. I know them when I see them. I just can't remember them right now. And basically, you learn. Okay, I think you learn is arene. No, alkane, alkene, alkyne, and arene. Okay, the alkane is basically any organic compound with just simple bonds. Pretty simple. Alkene is anything with double bond. Alkyne, anything with a triple bond. And an arene is a ring, also called benzyl ring. But you must be very careful, okay, because there are arenes that aren't really arenes, okay, they are a ring. But if there's benzyl rings, okay, the benzyl rings always have, I think, two double bonds, and if it's missing just one of them, it's not a benzyl ring, it's a cycloalkene. It's pretty confusing, but don't worry, you only do like 10 exercises about it, and that's it. It's pretty simple. After that, we did slime in the lab. It was pretty fun. It's pretty fun, actually, the best part. Oh, also lab practicals. You are gonna hate writing those things. Oh, especially if you pair it up with English projects, There are times, like, it's very likely they're gonna make a chemistry and English crossover. Worst thing, in my opinion. The chemistry teacher is going to tell you to do one thing, but the English teacher is going to tell you to do another thing. So you do the English teacher stuff because that's when you do the thing, but it's going to turn out to be wrong. And then they're going to raise your grade automatically because it was, not your fault. You did it wrong. That happened, I think, 3 times. That's pretty much English projects in a nutshell. There's not enough communication, so we get our grades raised automatically. Okay, that's not what it is about. And we also learned. Okay, we also learned how to draw these. Okay, so the organic chemistry, that the names that they give you. For example, a cyclohexane. Cyclo means circle, and hexane, the hex means 6, and ane is for an alkane. Basically, a circle, not exactly a circle, a hexagon of simple bonds. That's a cyclohexane. Cyclopentane, cyclooctane. It's pretty simple stuff, and from then you get like 1,3 cyclohexane pentai. I don't know, something here, and that's how you draw stuff. It's pretty fun. Actually, that's my favorite part of the course. I kind of wish we did more of it, but I also know I'm kind of too smart for my own good sometimes. And my other classmates, they couldn't really do it that well, so for their own sake, I'll leave it as it is. And so last thing, any comments on the course? I would like to say it's really good. I suggest to tone it down a little bit with the writing part. No one enjoys it. We do enough of that in other classes. I suggest more lab practicals. We never did a baking soda volcano, or that's actually an experiment I can think of. Maybe we could do more slime sometime. Oh, you know what we never did? We never did that Newtonian liquid thingy. That would have been interesting. Although I have no idea how we would take it home. Probably the same as slime. Just bring a jar. Jars are so weird. They're like bottles, but the lid is really big. Like what makes a bottle and a jar? Like, are bottles just really tall jars, or are jars just really wide bottles? I mean, I think we came up with jars before bottles, so I guess bottles are just really tall jars. As I was saying, more experiments, please. No so much writing, please. Tone it down on the making video stuff. Like, look at me. I've been talking for like 10 minutes now. I don't know for how long I've been talking, but I've been talking. Okay, what the videos actually means of like, make this thing and make a video about it. It's a pain to do them, and they always end up looking terrible. Believe me. No one enjoys looking at them. No one enjoys recording them. Tone it down with the videos. Maybe on audio. Audios are fine, I think. But no more videos, please. No videos. So as a final summary, I guess, I suggest more drawing stuff, no no video thingies, and more experiments, please. Uh, Also, we could make more like those activities. Do you remember? I remember now another thing we did at the beginning where we were looking at the electrons, the balance, not the balance, the balance, VALENCE. Those that balance. Uh, I T-posed in front of the entire class, pretending I was a sodium atom. That was the best part, honestly. We should do more of those. So yeah, I should probably stop before I end up recording. Oh dear God! I just checked. I've been talking for 15 minutes. About 16 now. Oh God! I should really stop now. So yeah, don't. Uh, Chemistry is it hard. More experiments. No more videos. More activities like T-posing in front of everyone to demonstrate how balanced electrons work. Yeah, that's it. Uh, can I have an extra point for the 16 minutes of this? Honestly, I could keep going, but I don't think the computer could handle it. So I'll stop now. Have a good day, evening, night, whenever you're watching this. If you're watching this, why are we even requested to make these videos? Please tell me you're not gonna show them to anyone. That is gonna be horrible. Like, just imagine the class having to look at a picture of me with probably some random effects for 16 minutes. Actually, about to be 17 if I don't stop the recording now, so I'll stop it now, and I'll see you on Thursday, I guess. How did